Construction is expensive, and we have a huge problem in this country. We have a lot of people and we don't have enough housing. And the only way we're going to solve that is to figure out how to make houses more inexpensive to build, houses that perform better, last longer, are more durable. And really, what we have to think about is how we make our existing housing stock better. This project is about a 6,000 square foot house in the hills above the Silicon Valley. We're going to talk about how we make this house more cost effective. Now, what does that mean? Well, when we originally came up with the design with the architects on this project, we talked about removing the roof and about putting exterior insulation on the roof and on the walls. Typically in passive house projects, you put insulation on the outside of your envelope to reduce the amount of conduction you get through the studs and to make sure that that whole building is more energy efficient. Here's the problem, is that on a house that was built 35 years ago, you have to think about the additional mass, the additional material you put on the roof and on the walls. And in earthquake country, like we are here, we have to think about how that information or that material makes it more difficult for that house to stand in an earthquake. So what happens in an earthquake is you have a house and then the earth slides. So the earth is actually pulling against the foundation, and the structure of the house has to drag the rest of the house with it. So what happens if the house isn't drugged with the foundation? The house falls off of the foundation or the house collapses like a house of cards. And so what we have to be careful of is when we add mass to the top of the house and to the walls of the house, we make it harder for that house to stay on that foundation. We put more structure load on that foundation. Now, why does that matter? Well, when we do a major remodel like this, we have to make sure that that house stands up to the earthquakes in the future. And that means that we have to do what are called seismic retrofitting. And a seismic retrofit means that we have to take all of the existing house, we have to tie it all together with nails and plywood and metal hangers, and then we have to anchor it all to the foundation. If that foundation isn't strong enough, we have to make it stronger. If those walls aren't strong enough, we have to make them stronger. So what does that mean to this house? Well, this house was built in 1990, which means that it matched 1990 code. Unfortunately, it only has 3/8 inch plywood on the exterior walls. That's not enough to stand the code for 2024. And so what we were going to have to do on this project is we were going to have to basically either tear off that 3/8 inch plywood around the entire house. So removing plywood from the outside of the wall because it's not thick enough by 1/8 of an inch. Then we were going to have to take new 1/2 inch plywood and we were going to have to nail it to all the studs around the entire house. That is an enormous amount of work. And what does that mean? Well, that means about $500,000 just in framing labor and framing materials. And that is just too much money for this project. And so we had to come up with a better way of upgrading this house and making it more energy efficient and making it airtight and making it insulative without adding a tremendous amount of load. So what did we do? Well, the architects came up with a great idea. We don't have to use this heavy tile roof. We can use a lighter roof. You know, those lighter roofs can include metal roof like standing seam. It can include like a zinc roof, which is very, very expensive, just the material itself. We can make a dimensional composition shingle like you see here. So there's lots and lots of options. So what does that mean for this project? Well, that means that if we can use a lighter roof, we're actually taking weight away from the top of the roof, making the house more resilient and more able to withstand earthquakes even with this existing structure. And we found that if we used a lightweight roofing material and took away this tile, we could actually use the existing house's structural framework and not have to do a seismic upgrade, even though we are adding insulation on the walls and the roof of the house. We are actually saving about $500,000 between roofing material, between foundation upgrades, between shear walls and framing upgrades, about $500,000 reduction in the cost of this project just by reducing the weight of the roofing material. Now this whole thing came about by a collaboration between our team and our subcontractors, the structural engineer and the architect. We had a $500,000 savings because we all talked together during pre-construction, not after we started construction and we tried to figure all this out, because by then it would have all been done and all of that money would have been spent. This is how you do pre-construction correctly. You get everybody talking, you find out what the values are of the client, and then you try to give them everything that they want for the least amount of money. If you're interested in learning more about building science or about building a better way, please hit subscribe as we show you how to build a better way.